Okay. So how are rate of change and slope related? Well, rate of change is the ratio of change in the independent variable with respect to the change in the dependent variable with respect to the change in the independent variable. A line has a constant rate of change, and the rate of change of a line is known as its slope. So often we hear rate of change and slope being interchangeable, and they're basically one and the same. So in order to find the slope of a line, what we do is we use this equation that is located right here. And how we go about solving this equation is let's locate two coordinates on the graph. So this one's 1 and 4, and this one is 2 and 8. And so I can go ahead and write here so you can see 1 and 4, 2 and 8. I'll say this is my x1 and my y1. This is my x2 and my y2. And so I just plug those values in. So y2 is 8, minus y1 is 4, x2 is 2, minus y1 is 1. And then you just subtract across. So m is equal to 4 over 1. 4 over 1 is equal to 2. So the slope or the rate of change in this instance would be 4. And so that's how you would use the slope formula to find the rate of change. Okay. We also have what is known as a direct variation, and we get the direct variation when a line passes through the origin. So if a line passes through the origin, basically the center point, which is 0, 0, that's the origin. If we have a line that passes through 0, 0, it contains a direct variation. A direct variation takes the form y equals k times x, where k is greater than 0, and k is called the constant of the variation. So basically, in order to find the direct variation, k is always going to be the same for any 2 points on the line. So for example, let me say I want to use this one. This is 1 and 2. And this one is 2 and 4. Okay, give me 1 second. So in order to find direct variation, hold on 1 second. Hello. Hello. Yeah. Okay, so for direct variation, what we're basically trying to identify is how y interacts with x. So for example, I'll use this one, the 4 and 2. So 4 equals x, 2. So basically what I did was input my x and y. And now I can isolate k. So k is 2. So basically, whenever I multiply a x value by 2, I can get my y. So we can check that by using this one on the bottom. And so the equation would then become y equals 2 times x. So say I'm looking for what the coordinate of 1 is, so 2 times 1. Well, then my y would have to be 2. So when my x is 1, my y would have to be 2. Does that check out yes here? Yes, it does. And so that's basically what direct variation is. It's how y relates to x. Okay? Okay. We also have what is known as an average rate of change. And basically, when the rate is not constant, we use an average rate of change to find the average rate of change. So we choose any 2 points on the line, draw a line through those 2 points, and then calculate the slope of the line. So basically, if the slope is not constant, if it changes throughout, what we can do is we can find an average rate of change to represent the slope of that line. So for example, here I could identify 0, 0, and here I could identify 25 and 12. I mean 2.5 and 12. So those are my 2 points. So now that I have those 2 points, what I can go ahead and do is find the slope. So here's my equation for slope. So 0, 0, 2.5, 12. This is my x1 and my y1. This is my x2 and my y2. Now I plug those in. So 12 and 0 and 2.5 and 0. That gives me 12 and 2.5. Now 12 divided by 2.5, that gives me 4.8. And so my average rate of change here would be 4.8. So basically the average rate of change takes the average of the entire line and gives you an average rate of change. Okay. Any questions about this? Questions, concerns? Okay. So here is an example in which we're asked to find the average rate of change. This one says find the average rate of change of the function on the interval 4 is less than, x is less than 4 and x is greater than 4 and x is less than 9. So basically what this is asking us to identify is what is our x and y when x is 4 and what is x and y when x is 9 and how do those two relate to each other? What is our average rate of change? And so the way we can go about solving this type of problem is we are given a function. And so what we are given is our x value. So we can identify what our y is in relation to that. So we'll start with 4. I did not need to make that big. Okay. So we'll start with 4. So 4 plus 1. The square root of 4 is 2. So 2 plus 1, which gives me 3. So whenever my x is 4, my y is 3. Okay, I can do it now for the 9. So basically what I'm using is the beginning and the end of my range or my domain in this instance and plugging those in. So the square root of 9 is 3, so 4. So whenever my x is 9, my y is 4. Okay, so now that I have these coordinates, I can plug this in to my rate of change equation. So let me identify this is my x1, my y1, my x2, my y2. My equation for rate of change is m is equal to y2 minus y1 over x2 minus x1. And now I just plug those in. So 4 minus 3 and 9 minus 4. Subtract across 1, 5. You can't simplify that any further. Oops, sorry. And so my average rate of change is 1 over 5. Okay, so whenever we're finding the average rate of change, if we are given a specific interval, we want to test the first x and the second x. And then using that information, given whatever our y is, now that we have our y's, we can plug that into the slope formula and find our average rate of change. So what is the average slope in this instance? Okay, any questions about this?
No, ma'am.
So that gives us the question, is the average rate of change always positive? Well, the slopes of lines are not always positive. They can be positive, they could be negative, or the slopes could be 0, which would be represented by a horizontal line. And we'll get into this more on Monday. So here's just an example. Between week 1 and week 3, the lines go downward. So in this case, the average rate of change is going to be negative during that period. The average rate of change between the initial value to the last value is, and we can go ahead and identify that. So basically, we have different types of rate of changes. We have positive, we have a negative, and we have what is known as a zero. And we'll look at what those look like. The more often than not, if we are looking at them on a graph, they're going to be identified by the way that they move. So a positive slope would go like this, a negative slope would go downwards, and then a zero slope would go horizontally. And so what this is saying is that from 1 to 3, the line goes down. So like this would be a negative, this would be a negative, this would be 0, this would be positive, 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 positive. And so basically we'll be able to identify how the slope changes, but if we're looking for the average rate of change, like we just looked at, the way we would find the average rate of change is we would take the initial and the last point, and then we would find how they relate to each other. So this one would be, this one would be 140. Six 140. 6 140, x comes first, and then this one would be 0 0. And so given that information, we can plug it into the equation for slope, where this is my x1 and my y1, and this is my x2 and my y2. Okay, plug those into this equation like we see here, and then solve. 140 divided by 6. What does that equal to? Approximately 23.33. 23.33 is a positive number, which we'll look at this a little further. And so this would be a positive slope. So the average rate of change would be a positive slope, and the average rate of change would be 23.33. And we'll look more on Monday at the difference between positive, negative, and zero slopes. Okay, any questions?
No, ma'am.
So what did we learn today? A rate of change or slope is the measure of the constant change from a line. And so we use the equation, m is equal to y2 minus y1 divided by x2 minus x1. And then the average rate of change is the slope of the line between 2 points of interest. So basically, if we wanted to find the average rate of change between 2 specific points, or if we wanted to find the average rate of change from the initial point to the end point, whatever we wanted to do, we could go ahead and find the slope or the average rate of change for any graph that we want to. Most likely it's for graphs that change slopes throughout time, like here. So we'd be able to find the average rate of change of that. So one specific number, we wouldn't be looking for every single slope on that line. Because as you can see, the slope changes 1, 2, 3, 4, 5, 6 times. And so instead of us having to identify all 6 of those slopes, all we would have to do is go from the initial to the end slope and find the average rate, or the average slope. Okay? Any questions about slopes or average rate of change?
No, ma'am.
All right, so that may have been a review of what you've seen already in algebra. We will get a little bit deeper into it on Monday. But if there's no other questions, you guys may log off, and I'll see you guys Monday. Bye, guys.
Bye, miss. Have a good day.
Bye, you too.